In this presentation, we are going to look at proportion tests. So single sample and two sample test for proportions. I'm going to use the R programming language as well. So in this procedure, what we want to do is we can determine whether or not we can be confident in assuming that the population proportion takes a certain value. So let's just say, for argument's sake, we are dealing with a country, let's say Ireland, where I am, and just say, for example, some sort of mobile device like iPhones or Android devices or something like that, something you can use the internet with. What we want to know is, suppose we believe that the population proportion of students with iPhones or Androids or devices like that was 80%. What we would do first off is we would state a null hypothesis and alternative hypothesis. So the null hypothesis here, this is the null hypothesis, is H0 is pi. Now this is pi is population proportion. That's how we might denote it. Pi 80%, and the alternative is pi not equal to 80%. Now I have it sort of written up here, but pi is, you might sort of like population, proportion of population, something like that, that of proportion of students who own device. Something like that. Just like make a little statement when you write these like null and alternative hypotheses. So that's it. So how might we do this in the R programming language? So the appropriate R command is prop.test. Okay. And we have three arguments here. X is the number of successes in a sample, and N is the sample size. So let's just sort of consider this. Our sample is number of successes, X, and size is N. Okay, so our estimate is our p hat, so to speak, our estimate sample proportion is simply X over N. Okay, now P is the population proportion assumed under the null hypothesis. So you can't write pi when you type in pi when you're using R. So we just use P here. It's a little bit confusing. It was pi in the last page, but now it becomes P when we type it into the R programming language environment. Okay, suppose we survey 65 students with 55 replying that they have an Android or iPhone device. Okay, so our number of successes is 50 out of 65, and what we want to do is test the proportion, or the probability, or test the hypothesis that 80% of them have it. So what we'll do is type it in here like this: prop dot test 50, 65, and also our null hypothesis that the true proportion is 80, not 0.80. There we go. One sample proportion test with continuity correction. That bit is important because there's a sort of I'll talk about it separately, but essentially if we were to sort of do this by pen and paper, you get slightly different results. Okay. Anyway, the 95% confidence interval for the true proportion is 0.645 to 0.861. And first off, our sample estimate, p hat, is just slightly short of 0.77, 0.692308. And that's a 95% confidence interval for that proportion. Okay. Now, our null hypothesis is the opposite of this. So the alternative hypothesis is that true P is not equal to 0, and that means the null hypothesis is that it is equal to 0. Okay, and what we're going to do is use this p-value here, and we would sort of say the p-value is 0.64. That's not significant, it's massive. So in this case we fail to reject the null hypothesis. Also, so essentially, yeah, we could be our belief that the true proportion of students holding these devices is 0.8. That's pretty consistent. Sorry, it's not consistent. We've no evidence to not believe it anymore. Okay. Also, you might notice that 0.8 is in that range of values there, so that's also quite important. Okay. Now, the continuity test, the continuity correction is something that's I'll deal with at a different time. But essentially, our confidence interval, our estimate 0.67 is there. Just as a remark, if you were doing it by pen and paper, this is how you might get what you might get. You will get p hat, the proportion, minus pi, all over standard error, which is for confidence intervals, for hypothesis tests, it is pi times 1 minus pi over the sample size. Okay. Now remember, it's a little bit different when you're doing it for confidence intervals. That would be, scroll down here, 0.65, sorry, 0.8, or sorry, 0.77 minus 0.8 all over the square root of 0.8 times 0.2 all over n. Okay, and the n here was like 60. Okay. In that case, what you might do there is, I won't solve it, but essentially that's how you get your test statistic. Now, the thing is, actually, with a continuity correction, you get a slightly different test statistic from the way you sort of commonly do in pen and paper exams. Now, let's just sort of move on from that. What we could do here is a two proportions test. Okay, so that's it again. And let's just sort of get a formal reading that. So the p-value is above the threshold of 5%, or 0.25, depending what you're working with. Therefore, we fail to reject the null hypothesis that the population proportion is 80%. Okay, so the observed proportion is a very straightforward calculation, and you probably would be asked to show it. Now, second matter is two sample proportions. So let's move on to that. So what we might do is, this is like the one sample and two sample proportions. This is the two sample proportions. I'm just trying to bring it up here.